Hello, everyone. Welcome back to online class. Today, we are going to look at how to solve linear systems of algebraic equations. And in particular, we are going to look at Jacobi iteration method. So we have this question. We are given the system below, as you can see. We are asked to use Jacobi iteration method to solve the system, starting with the initial guesses that x1 at level 0 is 0, x2 at level 0 is 0, and x3 at level 0 is 0. Perform 3 iterations. So let's see how to go about this kind of problem. Remember, Jacobi iteration is simply an approximate method. It won't give you the exact solution. So we are going to look at 2 different ways of solving that system using the same method. The first one, or you can write method 1. You write method 1. Here we are going to use matrix vector form. Use matrix vector form. Now let's see how to write this system in matrix vector form. Remember, we have 3 equations. We can write them in matrix vector form as you start by, first of all, writing the coefficient matrix. That is 5, 2, 1. That is in the first equation. The other one is 1, 4, 2. Then 1, 2, 5. This is the matrix of coefficients. Our unknowns are x1, x2, x3. The solution matrix is 12, 15, 20. Or in general, this can as well be written as A times X is equals to B. This is the general form of a linear system of algebraic equations. So in this case, our A is the coefficient matrix. Our X is the unknown column vector. And the B is the right-hand side, or simply the solution matrix. Now remember that the coefficient matrix A can be decomposed into 3 components. So you can write a note that A can be decomposed into 3 components, that is L plus D plus U, where L is the lower triangular matrix, D is the diagonal matrix, and U is the upper triangular matrix. So in this case, therefore, our L, look at the diagonal of A. Diagonal elements, these ones. So below the diagonal, what are the values? The values below the diagonal. So anything on the diagonal or above the diagonal, you write 0. So we'll have 0, 0, 0, followed by 1, 0, 0, followed by 1, 2, 0. Our interest is the elements below the diagonal. Now, the diagonal matrix D is equals to, now the interest is on the elements that are lying on the diagonal, the leading diagonal. So 5, the rest are zeros, so 0, 0, 0, 4, 0, 0, 0, 5. And lastly, the upper triangular matrix, you look at the elements that are lying above the leading diagonal. The rest are zeros, so we'll have 0, 2, 1, 0, 0, 2, 0, 0, 0. You see, when you add L, D, and U, you get back to the coefficient matrix A. So that's how to decompose A. So having found L, D, and U, now this is the Jacobi iteration. This is the formula that we are going to be using. So you can write the iterative formula is, so simply the Jacobi iterative formula is x, the vector x at level k plus 1 should be equal to h times the vector x at level k plus a constant c, constant vector. Now, how do we find h and c? So you can write where, in this case, h is given by, it is a matrix that is given by negative D inverse times L plus U. That's how to find H. And the C is given by D inverse times B. So we'll need to find those matrices before we start the iteration. Let's find H and C. And you also know how to multiply matrices. First of all, you need to find D inverse and then multiply that by the sum of L and U. So this is what you're going to get. Let's start by finding D inverse. So you can write now our D inverse. You know how to find the inverse of a matrix? Use any method of finding inverse of a matrix. Remember, you have two methods. You could use what we call the Gauss-Jordan elimination method. You will also use the cofactor expansion method, or you could also use the Cayley-Hamilton theorem to find the inverse of a matrix. So once you do that, you need to find your D inverse as 0.200, then 0.250, followed by 0.2. So this is our D inverse. I also need L plus U. L plus U is this matrix. You simply add them. When you add L and U, you need to get 0, 2, 1, 1, 0, 2, 1, 2, 0. So now we need H. You can say that therefore H is equals to negative D inverse times L plus U. So it will be negative. Our D inverse was 0.200, 0.250, 0.2. Multiplied by L plus U, that is 0, 2, 1, 1, 0, 2, 1, 2, 0. When you work out, you need to get 0, negative 0.4, negative 0.2. Second row, we need to get negative 0.25, 0, negative 0.5. Third row, negative 0.2, negative 0.4, and 0. So that's our H. Let us find C. So our C, the vector C, is D inverse times B. Our D inverse is 0.200, 0.25, 0.2 times our B. On the right hand side it was 12, 15, 20. Remember, you're multiplying rows times columns, and when you do that, you need to get 2.4, 2.40, 3.75, and 4.00. So now we go back to the iterative formula and replace H and C. Remember here, K ranges from 0. You can write for K is equals to 0, 1, 2, 3, etc. So this is the iterative formula. Now we have the values of H and C. Let us substitute them and now find, because we are given, simply we are asked to find 3 iterations or perform 3 iterations. And we also know the initial estimates. This 0 up here is simply the level. So let's go back and now work it out. Now, you can write given the initial estimates as, so you write given that x1, remember those are the unknowns, at 0 is 0, x2 at 0 is 0, x3 at 0 is 0. This simply means that the vector x at level 0 is simply equal to the 0 vector with 3 elements. So let's perform the first iteration. So write first iteration. That means you put k is equals to 0. Put k is equals to 0 in that iterative formula. That will give us x1 at level 1, I mean, is equals to h times x at level 0, which we already have, plus c. And so let's replace them. Our h we got as 0, negative 0.4, negative 0.2. Here we have negative 0.25, 0, negative 0.5, negative 0.2, negative 0.4, 0, This should multiply 0, 0, 0, and then you add to C, which is 2.40, 3.75, 4.00. And so when you work out this, we're going to get 2.4, 3.75, and 4.00. So the answer here is 2.40, 3.75, 4.00. What does it mean by these values you are getting? It's simply that 2.40, this simply means that x1 at level 1 is 2.40, x2 at level 1 is 3.75, and x3 at level 1 is 4.00. That's the first iteration. Let's perform the second iteration. So you can write here, second iteration. Here now we put k is equals to 1. So we are going to get x vector at level 2 is equals to h times x vector at level 1 plus c. If I substitute h and c and even the x vector at level 1, we are going to get this. Let me replace h. That was 0. Then negative 0.4, negative 0.2, negative 0.25, 0, negative 0.5, negative 0.2, negative 0.4, 0. That's our h. Multiplied by x1, that is 2.40. I mean x at level 1. Here we have 3.75, 4.00, plus our c, 2.40, 3.75, 4.00. When you work out, you need to get your answer as this column vector 0.10, 1.15, 2.02. What does it mean by these values? Is that x1 at level 2 is equals to 0.10. X2 at level 2 is 1.15. X3 at level 2 is 2.02. And finally, the third iteration, so you write third iteration. Now in this case, you put k is equals to 2. And so what are we going to get? That the x vector at level 3 is equals to h times the x vector at level 2 plus c. When you substitute those values on the right hand side and you multiply, this is what you need to get. Of course, you know, now we are going to use x vector at level 2. H, we know it, and c, we also know it. I don't need to write everything because you can substitute and multiply. This will give you this column vector. You'll need to get 1.536, 2.715, 3.520. And so the interpretation here is that x1 at level 3 is equals to 1.536. X2 at level 3 is 2.715, and x3 at level 3 is equals to 3.520. So it means that this is the approximate value of x1, this is x2, and this is the approximate value of x3. Remember, we cannot get the exact value. If you proceed with the iterations, you can get to the exact value, because once you achieve convergence, then it means the value that your approximate values are converging to, that is the exact value. But because we are told to perform only 3 iterations, so we need to stop there and then conclude that those are the values of x1, x2, and x3. Now, there's another method where you don't have to use the matrix vector form. So you can write method 2. Method 2. You see, in method 2, the given system can now be written as, look at our first equation. It was 5x1. Let me write them here. 5x1, so that I explain how to write in terms of Jacobi form. 5x1 plus 2x2 plus x3 is equals to 12. The other one is x1 plus 4x2 plus 2x3 is equals to 15. Another one is x1, 2x2 plus 5x3 is 20. So what you do here is that look at the very leading coefficient in the first equation, or the first term. Again, in the second equation, you make x2 the subject. In the third equation, you make x3 the subject. It means the rest I'm going to take to the right-hand side. So from here, I'll have, if I make x1 the subject, I'll have x1 is equals to, because I'm going to divide by 1 over 5, so it is 1 over 5 times negative 2x2 minus x3 plus 12 over 5. somebody might be wondering why negative, because I'm going to take this to the right, also this to the right, so they become negative. Now, once you make x1 the subject, in equation 2, you now make x2 the subject. So this will give us, so it means I'm going to be dividing by 4. So right here, x2 is equals to 1 over 4 times negative x1 minus 2x3 plus 15 over 4. That means I've taken x1 to the right and also this to the right. In equation 3, you make x3 the subject. So that will give us x3 is equals to 1 over 5, dividing by 5, negative x1 minus 2x2 plus 20 over 5. So you need to take note that equation 1 will give you the value of x1. Equation 2 will give you the value of x2. And equation 3 will give you the value of x3. The rest you take to the right hand side. So having done that one, now on the left, you put the level as k plus 1. In each of them, k plus 1, even near k plus 1. On the right, the level is k. So level k, even this one k, each of them we put at level k, k, k. So that is the Jacobi iteration. You don't have to use matrices, because you see sometimes getting the inverse of a matrix might be very difficult. And so it is better to go for the easiest method. So once you have them as that, the next thing is to now perform the iteration. So we are also given that x1 at level 0 is 0, x2 at level 0 is 0, x3 at level 0 is also 0. Those are the initial estimates. So you perform the first iteration. First iteration, we are going to put k is equals to 0. Remember I said here for k is equals to 0, 1, 2, 3, etc. Depending on how many iterations you want to perform. So when k is equals to 0, what are we going to get? Let's start with the first equation. x1 at level 1 will be equal to 1 over 5 times negative 2x2 at level 0 minus x3 at level 0 plus 12 over 5. That should be 12. Let me change it. Plus 12 over 5. Substitute the values, so this will give us 1 over 5. Negative 2 times 0 minus 0 plus 12 over 5. And so that should give us, of course, 12 over 5, which is 2.40. So the answer here is 2.40. Equation 2 will give you x2 at level 1 is equals to 1 over 4 negative x1 at level 0 minus 2x3 at level 0 plus 15 over 4. And so when I substitute, I'm going to get 1 over 4 minus 0 minus 2 times 0 plus 15 over 4, which will give you 3.75. Third equation will give us x3 at level 1. It's 1 over 5 negative x1 at level 0 minus 2x2 at level 0 plus 20 over 5, that is 4. 20 over 5 is 4. When you substitute the values of x1 at level 0 and x2 at level 0, we're going to get 1 over 5 into negative 0 minus 2 times 0 plus 4. And so that will give us 4.00. That's the first iteration. Second iteration. In this case, now you put k is equals to 1 in the iterative system. This is our iterative system. So with k is equals to 1, what are we going to get? We start with the first equation. When now k is equals to 1, we are going to get x1 at level 2 is equals to 1 over 5 negative 2x2 at level 1 minus x3 at level 1 plus 12 over 5. Replace the values, that's 1 over 5 negative 2. x2 at level 1, we already found it. It's this value here, 3.75. Minus x3 at level 1, that was 4. Plus 12 over 5. Press this in your calculator. You are going to get your answer as 0.10. Second equation, x2 at level 2. That's 1 over 4 negative x1 at level 1 minus 2x3 at level 1 plus 15 over 4. Substitute, you're going to get 1 over 4 x1 at level 1, that was 2.4 minus 2 x3 at level 1, that is 4 plus 15 over 4. When you press again, you need to get 1.15. Third equation, x3 at level 2 is 1 over 5 negative x1 at level 1, 2x2 at level 1 plus 4. When you substitute, you get 1 over 5 negative 2.4 minus 2 times our x2 at level 1 is 3.75. Add this to 4, press in your calculator, you need to get 2.02. And finally, the third iteration, here you put k is equals to 2. How will our system now look like when k is equals to 2? Now the first equation is x1 at level 3 is equals to 1 over 5 negative 2x2 at level 2 minus x3 at level 2 plus 12 over 5. So that is 1 over 5 negative 2 times 1.15 minus 2.02 plus 12 over 5. Press, you get 1.536. Second equation, x2 at level 3. That's 1 over 4 negative x1 at level 2 minus 2x3 at level 2. You're adding this to 15 over 4. Substitute those values. That's 1 over 4 minus x1 at level 2. We got 1 point, was it 1.10, 0.10, not 1. So that is 0.10 x3 at level 2, 2.02 plus 15 over 4. When you press this, you need to get 2.715. Finally, the third equation, x3 at level 3 is 1 over 5 negative x1 at level 2 minus 2x2 at level 2 plus 4. When you make the substitution, you get 1 over 5 negative 0.10 minus 2 x2 at level 2, that was 1.15, add this to 4. press in your calculator, get 3.520. So therefore, this is the approximate value of x1 after the 3 iterations. This is x2, and this is x3. So I think the second method is easier than the first method, but always choose the method that is easier for you. Let's compare with the exact solution. Remember, you can be able to find the exact solution of that linear system. You could use Cramer's rule or matrix inversion method or LU decomposition to find the exact values of x1, x2, and x3. So this is what you'll get. Exact solution is, you will get x1 is equals to 1, x2 is equals to 2, and x3 is equals to 3. So look at our final values. Our x1 is 1.536, almost close to 1. Our x2 is 2.715, almost close to 2. And our x3 is 3.520, which is very close to 3. So it means if I were to continue the iterations, I will have gotten to the exact values because our solution will have converged to the exact values. So that's how to use Jacobi iteration method. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving iterative methods of solving a system of linear algebraic equations. Bye-bye.